Now, going from what we just said, if we're dealing with this triangle, and we know that it's an isosceles triangle, this length is the same as this length, and we know that this equals 40 degrees, then the other two angles must be equal and whatever's left over. So if you minus 40 from 180, all right, you're left with 140, all right, and half of that is 70. So that's how I get these two values, all right. So what I said was it's an isosceles triangle because I just discovered that these two lengths are exactly the same, all right, and I know that up here is 40, all right. So if you do 180 minus 40, you get 40, all right, and half of what's left, so 180 minus 40 equals 140, and half of that is 70. So you're going to have half there and half there, all right. So knowing that, this must be 30, okay. All right, because we've got 70, so we've got 40, we left over with 30, okay? Now, knowing all of that, because that's interesting because you've got the 20 and you've got the 40, okay, 60, 70, 80, 90. So, in fact, this angle here, this entire angle is 90 degrees, all right? Which actually means the drawing in your diagram is, in your book is not actually particularly accurate in the way it's been drawn. Because if that angle there is 90, that means that this must be 270, which means this is at right angles here. All right. Anyway, working out this length here, you can just use, now that you know this angle here, you can just use a sine rule again. All right. You're going to have to use one of the ones that you've already worked out. Okay. So the 193.04, you can use that along with the 70. All right. And your 40 degrees and your unknown is going to be across there. Okay, and I think I need to draw that on a separate page.